The research and national defense facilities of the Oak Ridge Reservation are vital parts of our nation's scientific community. To continue to meet these needs, parts of the reservation require cleanup from the impacts of years of energy research. The Oak Ridge Site-Specific Advisory Board is the voice of the community, providing input to the U.S. Department of Energy on its environmental cleanup of the reservation. To learn more about this important work, you're invited to attend meetings of the Oak Ridge Site-Specific Advisory Board.
Good evening, everyone. Welcome to the May Oak Ridge Site-Specific Advisory Board meeting. Go over a couple of quick things on our protocol. We welcome members, of course, and people from the public, and please sign in and use your name tags if you wish, and always try to speak into the microphones. I know I don't. Members, as always, use your tents. And during the presentation question and answer period, the board members go first, and then the public will have an opportunity to ask questions at the microphone. Next month, on June 12th, we'll have a presentation on the National Environmental Management Program. With that said, we'd like to get some comments from Sue Caines.
Good evening, everybody. First and foremost, I would like to read some biographies as a part of a welcoming of some new student representatives that we have to the board tonight. So first we have Miss Julia Riley. Julia, raise your hand so you can be acknowledged. Julia is a rising senior at Hardin Valley Academy, where she participates in the National Honor Society, the Leo Club, which is a Lions Club organization, and Venture Crew, which is a co-ed branch of the Boy Scouts. Julia loves to spend her free time outdoors hiking and backpacking, and as of right now, she wants to pursue a wildlife and fisheries biology degree at Clemson University. So, welcome and good luck to you with your endeavors, Julia. We also have Gracie Hall. Here's Miss Gracie. Gracie is a rising senior at the Oak Ridge High School, where she is a member of the National Honor Society, the Oak Ridge High School Marching and Concert Band, and the International Relations Club. Gracie also sings in Sound Company Children's Choir and practices various forms of martial arts. Gracie hopes to obtain a degree in Spanish, do service work in other countries, and pursue a career that allows her to work with animals. I have some other things that I was going to share with people. Thank you.
All right.
First and foremost, I just wanted to recap an important event that we had last week here in Oak Ridge, and it was our EM celebration, a celebration of all of the accomplishments of the Environmental Management Program since program inception back in 1983. I hope that some of you were able to participate in that celebration. We had a number of visiting dignitaries, including Dave Huizinga, the Senior Advisor for the Environmental Management Program, Commissioner Martineau from the Tennessee Department of Environment and Conservation, Deputy Regional Administrator Stan Myberg from EPA Region 4, and a number of our state and federal congressional representatives. The events were well attended by several hundred people. We unveiled a video that was produced as a part of our oral history project for historic preservation that featured 3 of our former Oak Ridge office managers that all had key roles in helping to advance the environmental management program. And again, it was a celebration that I think was very well received by people. The next day, we had a meeting with Senator Alexander over at Y12 with a roundtable discussion to talk about the Mercury that is needing to be addressed at the Y12 site. And the senator followed it with a press conference where he and Mark Whitney, the manager for the Environmental Management Office, and Commissioner Martineau and Deputy Regional Administrator Myberg all talked about the Outfall 200 project, which I believe you all have been briefed on by Laura Wilkerson. So that was also a very interesting event. As far as what's going on internally within the DOE Environmental Management Program, we have received our budget guidance from headquarters on the preparation of the fiscal year 2015 budget. So we are very busy at work trying to put together a number of different planning scenarios. And as a part of that, I did want to also mention that we have reached agreement with EPA and with the state of Tennessee on our out-year planning milestones, which cover the period from fiscal year 2016 and beyond, which shows an alignment amongst the three parties on our various priorities and whatnot. So that was it. That was all I had. Thank you.
Okay. Now, David?
Nothing for me this month, thanks.
Okay. All right. John Housley, our TDEC liaison, you have anything for us today?
Thank you, sir. I have no announcements, but would be glad to attempt to answer any questions the board may have.
Okay. Thank you, John. Miss Connie Jones, the EPA liaison.
Thank you. I don't think I want to spoil anything. I don't have anything to offer at this time, but I'd be more than happy to try to answer questions if asked.
All right. We appreciate
Thank
that.
you.
Okay. Mr. Jensen, you doing the public comment?
The public comment period is now open. As a Citizens Advisory Board to the Department of Energy on environmental cleanup, we want to encourage the community at large to attend and participate in our board and committee meetings. If you are unable to attend, please send in your questions and comments to the address shown on the board. Appropriate comments and questions will be read during the public comment section of the SSAB meeting and will be given the same consideration by the board and DOE as those given in person. Meeting schedules and ways to communicate with the board can be obtained by calling 241-4583 or by visiting our website.
Tonight's presentation is the remediation effectiveness report. I'll mention that this basic report was given at our stewardship committee meeting back in, I believe it was March, and David Adler and DOE worked diligently to get it scheduled here for the full board. I think it's going to be well worth the board's time to view this. So, David, would you introduce our speaker, please?
Gladly, Mr. Chairman. Speakers tonight are Jason Darby and Dick Keitel. Jason is a project manager on the Environmental Management Y-12 project team. He has worked for the Department of Energy for 17 years on the formerly utilized Sites Remedial Action Program and the Oak Ridge Environmental Management Program. He has also worked for the U.S. Environmental Protection Agency and the U.S. Geological Survey. He is currently responsible for mercury reduction work at Y-12, future disposal facility planning, environmental monitoring at Y-12 and ORNL, and issuance of annual remediation effectiveness report, that's the RER, and the CERCLA 5-year review. Jason received his Bachelor of Science degree in Geology from Virginia Tech and his Master's of Science degree in Geology from LSU and resides in Oak Ridge. Dick Keitel, who will continue the presentation, presently serves as the technical lead for a UCOR Water Resources Restoration Program, where his responsibilities include a wide variety of groundwater and surface watering monitoring and remediation activities. During his career, Dick has participated in a wide range of environmental investigations and assessments, including surface water and groundwater contaminant transport, environmental impact assessment, and he has supported major Department of Energy environmental management remediation projects at the Oak Ridge Reservation. Dick received his BS and Master's in Science degrees in Geology from the University of Tennessee. Gentlemen, the floor is yours.
Okay, I'm going to introduce the RER and what it's all about, why we do it, and talk about one component of it. Just a couple of slides here, and then I'll turn it over to Dick to talk about the majority of the work we do, the data evaluation, the conclusions we draw. The RER has been around since about 1996. Back prior to that time, we collected a lot of environmental data, and it really wasn't put together in one location and wasn't published and made available to the public. So there was a desire on the part of the three FFA parties, the state of Tennessee, EPA, and DOE, to gather this data together, put it in one location, and make it available. So that's when the RER was created, about 1996. The primary purpose is to determine the effectiveness of remedial actions in achieving a stated goal. So the first thing we do when we're going through this every year is we look back at all of those decisions and what those goals were, whether it was a numerical goal to reach a certain level for a contaminant in surface water, whether it was a goal to contain contamination in a given site, a given footprint. We start with that, and then we look at the data we've collected to evaluate whether or not we're meeting that goal. Another component to the RER is the long-term stewardship evaluation we do, where we have actions that have left waste in place that would pose a risk to human health. There are controls that action created and that we implement to protect individuals from exposure. So annually we look at those controls to make sure they're being implemented, and that's something like a cap over a landfill that would prevent someone from getting exposure to the waste, or a fence that would prevent access to an area that's contaminated. So that's an ongoing thing. Those controls have to be in place, and so we evaluate that implementation each year in the RER. The scope of the RER includes stewardship activities, as I mentioned, evaluation of those activities. And it's important to note here, we're talking about fiscal year 2012 in this document. This document is the 2013 RER, but it's based on data collected in 2012. So when we're talking about things like that second item, ongoing action status, that's going to be status as of the end of fiscal year 12 in this particular document. So you may know just from these meetings here that certain projects are further along than this document indicates. That's because of that cutoff. We've got to end it on the FY so that we can begin reviewing that data, evaluating it, writing a report. And then, of course, monitoring results are a big part of the document. Again, that's FY12 data that's been collected that we evaluate. Dick will speak to that. Based on those results, we make a determination of remedy effectiveness. Is the action meeting the goal that was defined in the decision document for that action? And depending on that aspect of our evaluation, remedy effectiveness, we may have an action or recommendation that comes out of our evaluation. If we think a remedy is not currently meeting the goals for that remedy, there may be an action or additional investigation or planning to modify that action. There can also be recommendations just on our monitoring program. If we find the monitoring program is not adequate, we need additional locations, additional parameters, increased frequency, something like that, we'll make recommendations in this report to increase or change the monitoring. And that starts us down a process of formal approval of those changes and then implementation of those changes. So, as I mentioned earlier, one piece of all this is stewardship verification, that we're implementing all of our stewardship requirements that are called for in the decision documents. This year we looked at 55 surplus sites. There are over 200 checks that go along with that verification. These sites include 7 treatment systems, so it's not only landfills and areas of contamination, but active treatment systems like the East End VOC Plume at Y12 that controls carbon tet from migrating off-site, like the Core Hole 8 groundwater collection system at ORNL. We verify that land use controls are being implemented all across the reservation, but in Melton Valley we have something unique. In addition to that verification, we also certify that those controls are being implemented. So Mark Whitney would certify that those controls are implemented in 2012. That's not required to be done elsewhere on the reservation, but in Melton Valley we do that. We also this year have an additional appendix, Appendix D. It's a crosswalk that's huge that tracks the slabs. These are building slabs across the site. It's probably a third of the document. It's so thick, and it identifies these slabs, what the decision document was for that, any kind of completion document like an RER that would describe controls on that slab, monitoring requirements. That's all tracked. A lot of detail in that. So based on this year's evaluation of stewardship implementation, we found that there were no issues or recommendations needed, that all stewardship requirements were being implemented. So at this point, I'm going to turn it over to Dick, who will get into detail on all the data and the evaluations of that data.
I'm going to go through the RER summary at a very high level and as quickly as I can, because I know you've got a pretty busy agenda to get through tonight. So it'll be diving in and starting with significant activities in 2012 in the Upper East Fork Poplar Creek watershed, the Y12 plant site area. I'm going to start with some of the stuff that was kind of fun to be involved with last year, which was some of these mercury reduction project activities that Jason's been in charge of ramrodding through. We did 5 different mercury reduction projects. One was installation of mercury traps in some of the storm drains back up in the western end of the plant site. The purpose of these traps is to catch elemental mercury that's in the pipes into a little sump and then be able to remove that mercury from its involvement with the environment. B&W Y12 did the work on that, and it's pretty effective at getting mercury that's really still rolling down the bottoms of some of those storm drains. We conducted a treatability study and conceptual design for the fabled Outfall 200 mercury stormwater treatment system. This involved CH2M Hill, which is one of the partners in the UCOR company that's now operating EM at Oak Ridge. We did a lot of stormwater sampling within the storm drain network and at Outfall 200. Did laboratory testing of that to understand the forms of mercury that are being discharged and how to treat that contaminated water, and prepared a conceptual design report based on the work that we did in that treatability study. There was also a mercury contaminated soil treatability study for how to stabilize mercury contaminated soil so that it can be most cost effectively disposed without producing future risk to the environment. Designs were completed to retrofit selected of the drains at Alpha 4, Alpha 5, and Beta 4, which are 3 of the former process buildings that have a lot of mercury contaminated within the buildings. And some of that is still actually able to get out into pipes that exit the structures. So there was design work done to basically block off some of those pipes that are still releasing elemental mercury from the building. And last but not least, we removed 5 tanks that were formerly used for mercury processes. They'd been sitting in storage at the west end of the Y12 site for decades, and so they were successfully emptied of their residues, which included a fairly significant amount of mercury in one of them, and they were hoisted up and transported safely off-site to be size reduced and disposed. So that's real progress in attacking the mercury problems at the Y12 site moving forward. Other significant work that got done included soil remediation was completed at the old salvage yard, which was a large scrap metal storage area near the western end of the main plant area there at Y12. Some of these other activities are issuing paper PCCRs, phased construction completion reports, for other projects that had been completed a little bit earlier. 11.7 acres, including the 8110 former mercury recovery process site, was characterized, and a remedial design work plan was prepared for that site. This area has elemental mercury in soils related to a former roasting operation where mercury contaminated material was processed for disposition.
Where is that?
It's about midway up the Y12 plant on the south side. And then there were approval of some remedial action reports for D&D activities that had been completed in 2011. Now let's see if I can work the forward button. Yeah, this is a map showing the Upper East Fork watershed. The city of Oak Ridge is over here in the northeast corner of the map. The former mercury use buildings are over here in the far west end, shown in the pink stippling area. Outfall 200 is located right here where the blue line of the Upper East Fork ends. Upstream of that, all water is transported through a network that consists of miles of storm drain pipes. And all of that storm drain water emerges to daylight right here at Outfall 200. The Big Springs wastewater treatment system, which is another mercury treatment system, is located about midway down the plant area here. And it's been in operation since 2006 approximately, capturing and treating mercury contaminated water that formerly discharged via a spring that flowed through a storm drain out into the Upper East Fork Creek. The stream then flows further to the east, goes through a culverted section, then bypasses the old New Hope Pond area, which used to be a flow-through element of the stream system, then passes Lake Reality, which is an emergency catch basin, and then leaves the Y-12 and the DOE property here at a monitoring location that we know as Station 17. This is where you basically leave the DOE land and head off down into the city of Oak Ridge area. I'll comment that the Y-12 East End VOC Plume pump and treat system is located right in here, and that captures a carbon tetrachloride plume that formerly discharged over to springs along Illinois Avenue over here near the Arboretum area. That pump and treat system has been running since about the year 2000, and we've actually seen the carbon tetrachloride and other VOC concentrations decrease below their drinking water limits in the monitoring wells, and they're not detectable in the springs where they formerly discharged off-site out there. So that gives you an overview. The stippled and shaded area here is areas of groundwater contamination in the Upper East Fork plant site. This is the summary slide that I use for the Station 17 mercury discharges. This is where we're leaving the Y-12 site, heading down into the city. From back in the year 2000 through 2012. The lower slide here shows the annual rainfall that we have measured for all those 12 years now, showing where we've been below the long-term average of 54 inches per year and where we've been above that long-term average. And you can see that we're basically following multi-year cycles of below average and above average rainfall. And things look pretty good when we're in a drought because there's a lot less contamination that gets mobilized into the surface water system. But when you get into periods of prolonged above average rainfall, you can see that in Y-12 we're seeing elevated amounts of mercury that discharge out into the surface water system. And also here on the recent end in 2010, 11, and 12, we've seen large increases again in the mercury that's discharging. The mercury flux in kilograms per year is these yellow boxes, and the annual average mercury concentration are the blue points. Concentration numbers are over here on the right axis. So, for example, in 2012, the average concentration was around 800 parts per trillion. That's compared to the ROD goal for mercury concentration at Station 17 of 200 parts per trillion. So you can see one of the reasons here why we're very interested in trying to get some serious work going on to reduce these mercury discharges into the stream. One of the contributing factors to these elevated mercury numbers over here in 2011 and continuing in 2012 was discharges that occurred from the storm drain system during the WEMA storm drain cleanout project. The project had a lot of controls in place to try to capture mercury as they were cleaning sediment from some of the miles of storm drain pipe, but nonetheless there was contamination that got out and came down the stream, and we monitored it both up at Outfall 200 as well as seeing it down here at the lower end of the watershed. The concentrations have begun to turn over and head back down, and hopefully we're going to see that really begin to go back down over the next couple of years. But to attain and to reach and maintain the 200 parts per trillion goal really takes a lot more than relying on droughts to reduce the amount of mercury that's discharged from the site. This is a diagram of the east end VOC plume there at the east end of Y12, the carbon tet plume. Actually, there are two separate sources. There's a carbon tetrachloride source over in this area, and there's a tetrachloroethene, trichloroethene source up in this region. This is a sort of a merged plume of both of those types of volatile organic compounds. Formerly, that plume used to go all the way over here, as I mentioned before, to springs along Illinois Avenue. This area that's shown as stippled is the area where we've had the most effect on reducing the concentrations of the volatile organic compounds through the pump and treatment process that goes on here at our extraction well and air stripper system. In the RER, I've got tables that publish the amount of carbon tet that we've removed and treated, the amount of some of the other contaminants that we've actually removed and treated from the active system there. Moving over to Bear Creek, the Y12 plant, Upper East Fork, is located over here off the right side of the slide. The S3 ponds, which was a wastewater pond that was used for decades, is up at the head of this watershed. The EMWMF, Environmental Management Waste Management Facility, is located here in near some of the former waste disposal sites in the valley. The Bear Creek burial grounds are over in this area. In the Bear Creek Record of Decision, 3 land use zones were established. Zone 3 is designated as a waste management area. Zone 1, the cleanup goals for Zone 1 were for unrestricted use, in other words, environmental conditions that would not pose a risk to human health under something even as relaxed as a residential scenario. Zone 2 is a buffer region that separates the really clean goal area from the waste management area. The past disposal activities in Zone 3 have resulted in widespread groundwater contamination and nitrate, uranium, technetium-99 that gets into groundwater as well as into surface water. And so we've got a number of monitoring locations that for some reason are showing up as these weird W-looking things. We've got a character problem with our PDF file. We sample at a lot of locations in surface water, monitor continuously the concentration and flux of uranium and nitrate down here at the lower end of Zone 3, which is our integration point for that record of decision. We also have a number of groundwater wells that we sample within the burial grounds area, as well as further down Bear Creek Valley, all the way down here to the point where the stream actually turns to the north and flows over and down into the lower end of Lower East Fork of Poplar Creek. This is the high-level summary slide for Bear Creek Valley, similar to the Upper East Fork. We've got 2 locations where there are uranium flux goals based on the ROD. One is up here at BCK 12.34, which is a goal for uranium discharges from the S3 ponds, and the other is a goal down here at this integration point that I mentioned. So again, we're going back to 2001 up till 2013 now on the way I've drawn this axis. The rainfall is the blue line. This is the same rainfall line that you saw before. The goal for BCK 9.2, which is way down at the west end, is this heavier dotted line. The yellow line is the actual average or the annual uranium kilograms that are discharged, and you can see even during the drought we weren't getting very close to that ROD goal for the uranium numbers in Bear Creek Valley. The green line is the goal up there near the S3 ponds at BCK 12.34, and the story for that area goes that we're okay when we're in droughts. If we're below average rainfall levels, we look decent, but when we get above average, we're over the goal for the record of decision. There are still actions to be completed on intercepting and treating some of the shallow seepage pathways into the upper end of Bear Creek from the S3 ponds area, and there remains to be large-scale permanent decisions for the S3 pond source and plumes. This is the way that the breakdown of that uranium went during 2012. About 39% of it came from the Bear Creek burial grounds, primarily down two of the tributaries, NT8 and NT7. About 38% of it comes from the S3 pond source area. About 12% of it comes from NT3, which is the location of the former Boneyard Burnyard disposal site, which was remediated but still has a residual uranium discharge. And then other sources account for about 11% of that total uranium discharge during the year. Moving forward to ETTP, a lot of D&D work, as you all are no doubt aware, has been going on at ETTP. A couple of notable things that were not really D&D. The chromium water treatment system at Mitchell Branch started operation in fiscal 2012. This system collects hexavalent chrome contaminated groundwater that was found seeping into a storm drain and discharging into Mitchell Branch, and treats it prior to discharge through the waste treatment system there that's been specially built to treat that particular source. Let's see, most of the K25 East Wing exclusive of the technetium area was demolished in FY12. K33 slab was removed in FY12. Demolition was initiated on the K25 north end. 22 structures were characterized in the Poplar Creek D&D, lining things up again for getting them demolished and disposed of. Much of the rest of what was going on relates to a lot of completion documents related to work that had been going on or was completed during the year. A lot of paperwork was accomplished. In our monitoring of surface water and groundwater at the ETTP site, we continue to see that contaminant conditions are generally stable. We're not seeing increasing trends in very many areas out there. There's one area near a remediated site where we're seeing a little bit of increasing volatile organic compounds, but generally conditions are stable in that regard. A D1 remedial investigation feasibility for Zone 1, which is the outer boundary portion of the ETTP site, was prepared and submitted for regulators' review. Included in that RIFS were groundwater, ecological protection, and land use controls that would follow on in areas where contamination is left in place. This map shows the area of Zone 1. This area was all included in that RIFS. This is actually the map showing the status of exposure unit cleanup in Zone 1 from the soils cleanup aspects of that project, and they're basically all complete at this point. In Zone 2, this is a similar map that shows the status of exposure unit soil characterization and cleanup work, and here you can see the green areas are done, yellow areas are characterization incomplete, and red areas are known areas where remedial actions are required on the soils. And since Zone 2 is really the core of the former process area for gaseous diffusion and its support facilities, there's a lot of residual contamination and a significant amount of additional work, future work to do based on the status of demolitions not complete, so you can't really get at the soil cleanup until the buildings get out of the way. Bethel Valley at ORNL, interesting things there. Again, a lot of D&D work was being done. Some of this is the wrap-up of ARRA funding that was available to support a lot of aggressive work at ORNL as well as Y12. Remedial actions were completed for 18 slabs and structures in the northwestern part of the ORNL main plant. PCCRs were approved for 34 building D&D project. A revised approach for the building 3026 hot cells was developed in FY 2012, and that work is ongoing now. Legacy materials in Building 3038. These two buildings are in the isotopes area, as we call it, which was the former radionuclide R&D and processing facilities. They actually fabricated some fuel materials there, manufactured and packaged medical radioisotopes, and all sorts of different things went on there. Let's see. Gaseous waste system upgrade was started in FY 2012. This has to do with collecting and treating off gases from hot cell areas and other contaminated parts of the facility that have to have the air captured and treated. We had approval of the phase construction completion report for a significant upgrade to the Core Hole 8 strontium-90 plume extraction system. That system had been installed in 1995, and after about 15 years of operation, we found that some elements of it were deteriorating and not performing to the degree that we wanted them to, so we added some additional extraction wells and totally refurbished the existing infrastructure that was the pumps and the electrical controls, the instrumentation that controls the pumps. And so that system is back online and doing better than ever now. And last but not least here, the tank W1A, tank shell and associated soils were finally completely excavated and disposed in FY 2012. I know that John Owsley and others at TDEC and the regulating community were very glad to see that go. It had been about a 15-year-long project to finally get that thing out of the ground and gone. And in addition, ongoing surface water monitoring. We monitor extensively at all the sites on the reservation. Here's a quick map of the Bethel Valley area. A couple of things I'm going to mention. Oh, the other thing is that remediation or the closure of SWASA 3 and the contractor's landfill was completed out here on the west end, and that area is now into post-closure monitoring. A couple of areas, the Core Hole 8 plume is located over in the western part of the main plant area, and I'll mention Mercury releases into White Oak Creek that emanate from residual mercury at building 4501. At ORNL, they pilot test, or they developed the mercury use processes that they went big scale with over at Y12. And so testing out how would it work if you tried to pump mercury through flange and gasket type pipes, they learned that flanges open up and mercury spills out. So there was a mercury spill at 4501 that gives us a legacy of mercury discharges, some of which was going out through stormwater down to White Oak Creek down here on the south side of the building. So in a moment I'll have a slide that shows some data from this monitoring point that we call WOC 105 from down here at the 7500 bridge as well. This is that very slide. This is this graph over here that shows all this noisy data back to 2004. The dark blue lines are the mercury concentrations down at the 7500 bridge, which is the exit pathway for surface water from the laboratory. You can see numbers were going up to over 500 parts per trillion at some times. In the stream, the light blue line, this is the WOC 105 location. We also were seeing spikes that got pretty high. In 2007, the basement sump water, which has got a lot of mercury in it, was diverted to the main treatment system at the laboratory. And we saw that a lot of that former activity of spikes in the creek calmed down. We were still seeing a little bit of spikiness, but the numbers are generally below the ambient water quality criterion of 51 parts per trillion, which is the state limit for mercury in surface water. A couple of spikes have occurred. There was a treatment plant upset condition back here. We traced a spike here in 2012 back to some discharges from a storm drain up on Fifth Creek. So there's still things that go on. But over here on the right-hand side, you can see the the mercury concentration in fish tissue in the middle part of White Oak Creek up in the plant area has now dropped below this 0.3 part per million regulatory threshold. Concentrations had been up into the 0.4 and 0.5 part per million in the fish tissue for years and years, and now we're seeing those levels drop down to be compliant with the EPA limits for human health consumption of fish tissue, which is good news. I mean, this is a good news story at ORNL because we've managed to get our fish tissue concentrations down within the acceptable range by reduction of the total mercury concentrations in the creek. And this is basically the only place so far on the reservation where we've accomplished that goal through this means. Core Hole 8 Plume, as I mentioned, we did a major refurbishment in 2012. As a result, we're measuring strontium-90 levels at White Oak Creek that are now within the range that's acceptable to the record of decision for Bethel Valley. Before we did the refurbishment activity, we were having issues that the strontium-90 getting into the creek exceeded the ROD goal. So this action has pulled us back into compliance with that ROD goal for Bethel Valley. Melton Valley, ROD actions were completed by the end of FY 2006. We've been in basically remedy operation and monitoring ever since that time. The operation is maybe a little bit more than you might think. Yes, there's a lot of grass on the caps. We have to watch that. We mow the grass a couple of times a year. Those caps were planted with warm season grasses, which are good for wildlife, better than fescue. Fescue is not much of a wildlife cover. But there's minimal mowing that's required on it. But in terms of the operation of the remedy, we've got a lot of down gradient groundwater collection systems around some of those capped areas to collect residual seepage. And so we have to keep those systems operating to their designed intention, which takes a little bit of work. And we treat, during wet months, 1.5 million gallons a month we collect the groundwater. During the summer and early fall, those numbers go down to like 250,000 gallons a month that we're pumping. There's that much variation depending on the season out there. During FY12 and into 2013, we had found that we were having some deterioration of the SWASA 4 down gradient trench operation, and so we shut things down sequentially through that 1,300 foot long French drain and pulled the sump pumps out and went in there and redeveloped all the wells that were in that French drain, reinstalled pumps and other equipment, and we've got that system back working better than it had been before the refurbishment activities. We continue to conduct monitoring extensively to demonstrate the effectiveness of the hydraulic isolation, the caps. And we had one issue that I'll talk about in a few minutes regarding that at SWASA 4. Also, we continue aquatic biological monitoring to watch the recovery of the aquatic ecosystem out there. We've generally been seeing good improvements in the species diversity in aquatic systems. Things are rebounding from the decades of impacts that occurred during the disposal operations in Melton Valley. Map of Melton Valley. The Bethel Valley area is here. Upstream water comes through the 7500 bridge, flows down White Oak Creek, down through White Oak Lake and the embayment, and ultimately discharges to the Clinch River. Melton Branch is the major tributary to White Oak Creek that drains areas up near the high flux isotope reactor back here and around SWASA 5 and joins White Oak Creek. These are the major capped areas where we do groundwater level monitoring continuously to track the level of the groundwater beneath our capped areas. The red lines here are down gradient groundwater collection trenches. This is that 1,300 foot long trench at SWASA 4. SWASA 5 is halfway surrounded with a great big horseshoe-like French drain system that's got quite a few pumps in it. We've also got a down gradient drain over here on the western side of the seepage pits, one on the eastern side, and then there's a little collector in that area. The large area caps have done a good job of really reducing the ability of rainfall to percolate into waste areas. There had previously been a number of smaller caps over parts of the SWASA 6 area as part of some RIC reclosure activities, but the small caps really didn't get the job done because we found that water would percolate in adjacent to those caps and make its way in and still get to the trenches. So the bigger the roof is, the drier the area is underneath of it. This map shows a lot of areas where we do surface water sampling, and it's a good map to just show the general layout of the remedial actions in the valley. White Oak Dam is our integration point where we sample groundwater or sample surface water continuously. The three major radionuclides, and for that matter, radionuclides are really the risk-producing issues in surface water at ORNL. Strontium-90, tritium, and cesium-137 have goals at the integration point that we attained actually before we had even gotten the caps done and the remedy completed, which is shown with these gray lines. We had our average cesium concentrations, our average strontium-90 concentrations, and our average tritium concentrations were already below the record of decision goals for those contaminants. And this was refreshing to see, and I saw something similar going on during the SWASA 3 capping last year. As soon as we began to put the covers over the burial grounds, the amount of contamination began to drop that was getting into the streams, which was it's a good indication that hydraulic isolation really is an effective remedy to some of these discharges. So we continue to see levels that are below the limits that the ROD set for these three radionuclides. You can see there has been a little bit of increase in the cesium. This is related to that trend for longer term above average rainfall that really does produce more groundwater seepage and carries more contamination into the creek. But we're staying within the ROD limits here. Melton Valley exit pathway and off-site groundwater issues. Past detection of DOE-related contaminants in the on-site exit pathway wells down near the Clinch River was followed by installation of a number of off-site groundwater monitoring wells. We only detected some DOE-related contaminants in the first round of sampling in a few of those off-site wells, and we have not seen DOE-related materials like radionuclides and volatile organic contaminants that we could trace back to DOE sources since the first sampling round, which was in 2010. DOE, however, provided permanent utility water supplies to a number of residents off-site to the west of the Clinch River, opposite of Melton Valley, just to make sure that there were not pumping stresses from too much groundwater withdrawal on the west side of the river that might induce groundwater flow beneath the river and into the area where people could pull it up into their wells. We continue to monitor 16 DOE-built off-site wells and 7 residential wells that we've adopted into the off-site monitoring program. That monitoring is going on semi-annually, and there's a data summary in the RER that discusses the monitoring and results, both of the off-site sampling wells as well as an array of on-site exit pathways. Off-site contamination levels, lower East Fork of Poplar Creek. We continue to have mercury and fish tissue exceedances off-site below Y12 down the lower East Fork of Poplar Creek area with the sort of mercury that's continuing to discharge from the site. That's not a surprise. We've got, in response to a 5-year review issue that came up in the 2011 5-year review, we've got an ongoing aggressive set of investigations looking at lower East Fork sediment, soil, surface water, and the mechanisms for methylating mercury and getting mercury from the environment into the fish. And that's ongoing work that we'll be reporting in next year's RER. Lower Watts Bar, Clinch River, Poplar Creek, PCBs in the reservoir fish have been there since the 1980s and before, and the trends continue downward for the PCB levels in fish. The mercury levels in Lower Watts Bar fish are below the EPA criteria and have been so, as far as I know, since monitoring started down there. So, issues and recommendations, as Jason mentioned, I guess we do an issue recommendation summary each year. There was one issue that we surfaced last year at SWASA 4. One of the piezometers that we used to measure the groundwater levels beneath caps showed an unexpected spike in the water level in September after a hurricane 6-inch rainstorm in one day came by. So we're doing investigations about that piezometer to figure out what's the likely cause of a water leak or a leak that would allow water to percolate in the vicinity of that particular piezometer, and then take an action to repair that cap in that area. This is an indication that really our approach to monitoring the effectiveness of the caps has some real merit to it, where we can see some anomalies in water levels and then go after hunting for a leak. We had a number of continuing issues that we track in the RER, the Melton Valley exit pathway and offsite groundwater. We continue to track, as I just described. Continued elevated uranium at the NT8 tributary to Bear Creek. We continue to track that. Discuss what might be done to try to reduce the uranium discharges. Zone 2 well installation in Bear Creek Valley to detect possible migration of groundwater contaminants from Zone 3 down to the west into Zone 2. This is an action that's continued from the previous year, which is being added to a Bear Creek Valley future groundwater ROD scope to address. Then there has been a land use conflict issue that's been surfaced at the Black Oak Ridge Conservation Easement over north of ETTP, where there's a recreational use area going on related to the greenway on the ridge. However, a part of that area was designated to be industrial use in the original decision. That use is going to be reclassified in an addendum to the Zone 1 interim ROD to make the area recreational, consistent with the Black Oak Ridge Conservation Easement. Then we closed out 5 previous issues that had been brought into 2012. And then there were a number of administrative and minor changes not worthy of talking about tonight here. So there's a summary of the remedial action status. This is a lot of fine print. I'm not going to read through it. If you get a copy of the slides, you can read through it for yourself. It's pretty much stuff I've already talked about. The RER is out for agency and public review. Comments are due to Jason Darby by July the 1st, 2013. Any questions, discussion?
Sure. David, you start off?
Yeah, Dick,
Yes.
Last year UCOR developed a program, which we call it the Land Use Management Program.
Yes, yes.
How has that helped you? Has that been effective in helping you do what you need to do?
Absolutely. The land use program is going very well. We've got a lot of the site operating information in there. One of the things that is really good about it is it's allowing us to more easily track the inspection processes for the areas that we have to go inspect, interact with people that are facility managers for parts of the remedy operations, like the guys that are in charge of the groundwater collection system. So it's proving to be very beneficial. It's going very well.
Good. I'm glad to hear that, because I kind of like that program. When I saw it, I see a lot of advantages where it can be used DOE-EM wide.
Right.
So, thank you.
Jimmy?
Dick, the water that you pump from the SWASA areas, what are you doing with it?
We pump it into the main wastewater treatment plant up at ORNL. So all that goes through piping up into the process wastewater treatment system where it gets treated to remove radionuclides and metals and organics and any mercury that would be in it before it gets discharged. So it's at an on-site treatment facility.
Jimmy, anything else? No. Okay. Tom?
The new Mercury plant, is it being designed to bring us into the, down below the goal during the rainy season or during the dry season or during the...
Well, right now it's at a conceptual design level, and we're still waiting for money to get here to take the next step. The effluent goal for that at the present time has been set to be consistent with the 200 part per trillion goal for the record of decision for Upper East Fork.
But at what level of water flow?
That would be, right now its capacity is being discussed at like 1,500 gallons a minute. So there will be some stormwater that bypasses during flows greater than that capacity.
And is the increased mercury due to the added rain, is it due more to the force of the flow or due to the volume of the flow?
There's a couple of answers to that. There still is residual contamination in the storm drains, and so flow velocities help mobilize contaminated sediment that's still back in there, and that pushes mercury out. The regulation is for total mercury. That's both the dissolved part and mercury that's contained in or on sediment particles. And so if you've got mercury contaminated sediment back in the pipe and you increase flow velocities during storms, you're pushing some of that out. Also, as you get elevated groundwater levels over time because of above average rain, then you get more mobilization of mercury from material that's hanging in the soil outside the pipe. So there are multiple causes of increasing mercury. There's still a lot of elemental mercury in the ground outside the buildings and spill areas, outside the storm drains.
And one more question.
Yeah.
The one area where the fish have less mercury in them,
Yes.
is that perhaps because all the mercury there has been washed away?
No.
No.
There's still elevated mercury in the basement sump water,
It's still
and
at the same
that's
levels.
being diverted to treatment.
And it's not due because
So
of
that it's because the discharges into the creek were rerouted to a treatment train.
Thanks.
Okay. Let's see, we have any other questions here?
One
Okay.
back there.
Since I live in a Watts Bar and the Thames River area, I'm very interested in that. How have, you said the fish had gotten better there?
Yeah, the PCB levels in fish down in Watts Bar have decreased.
How did this happen?
Over time, the PCBs in the environment get buried in the sediment, and so as there's deeper and deeper burial, as sediment accumulates in the floor of the lake, there's less and less of it that gets up into the water column.
So I understand then that they've said repeatedly that they could not dredge Watts Bar. That's because the sediment is going down.
Well, I think you're talking about the TVA ash spill.
No, I'm not.
No? Okay, there is legacy cesium-137 contamination in the Watts Bar Lake sediment also that originated from discharges at ORNL back in the 1940s, 50s, 60s. And that part of the sediment contamination problem down there is something that we watch. Whenever there's a dredge permit that's submitted to TVA, we review where that dredge location would be, compare it to data that we have about sediment. If we have data that allows us to make a judgment about whether there's any potential hazard, we use that data. Sometimes we go out and collect additional sediment samples related to these dredge permits. So there's not a blanket problem about dredging. It's a spot-by-spot issue.
The U.S. Department of Energy is cleaning up the Oak Ridge Reservation of residual hazardous and radioactive contamination left over as a result of decades of nuclear energy research. Much of that work has been influenced by the Oak Ridge Site-Specific Advisory Board, a citizens panel that provides independent advice and recommendations on DOE's cleanup operations. You're welcome to attend the meetings and be part of this important work. For more information, call us or visit our website.